Alright, this is second video for today. We are going to be working with repeating decimals. What's nice about this section is it's very similar to our last section, which was called fractions to decimals. Because we're basically taking fractions and we're bringing them to decimals, but we're going to talk about a specific example of when it doesn't work out particularly well. Okay? So, for our little real-world example at the beginning, we have Jason is helping his older sister babysit for a week over the summer. And his older sister earns $385. And she tells them that he earns... Oops. 1/3 of the total profits. So the question is, if we do 385 over 3 to get 1/3 of it, what is that in money? And we will quickly notice that we'll have a problem doing that using our method that we did previously with our long division. There are two different kinds of decimals that we will find when we are converting from fractions to decimals. So fractions to decimals. And we've been mostly looking at what we call terminating decimals so far. These are numbers like 0.5, 0.75, 0.625, 0.1. These are nice because they end. They have an end point that I can definitely see when I'm writing out these decimals. However, there's a second kind that we will start to see when we're dividing particular numbers, and we call these repeating decimals. For example, a simple one that I see a lot is if I take 1/3 and I write it as a fraction, or as I write it as a decimal, it looks like this: 0.3, 3, 3, 3, and it has 3 repeating forever. So, as a lazy mathematician, I don't want to write out all those 3's. So the way that I can write this out, there's a trick for it. I write 0.3 with a line over it, and that tells me that there's 3's all the way back. There's an infinite number of 3's as I'm writing them. Sometimes it can be a whole set of numbers that are repeating. So if I have a number like this, 0.123, 123, 123, I can see that just the 1, 2, 3 continues to repeat over and over. So I can write it like this: 0.123 with a line over all 3, showing me that each of that set repeats over and over. Okay, so for this section, we're going to be doing the same thing that we did before. I'll put one more example up. Another common one is this: 0.1666666 forever. And I could write this, just the 6's are the repeating part. I would write it as 0.16 with a line over the 6, showing me that the 6's kind of continue on forever. Let's take a look at an example. All right, we're going to convert 5/6 to a decimal. Remember our rules for converting to a decimal? All we do is convert just like before. Oops, excuse me. We're going to convert using long division. Sorry, let's go find our rules from before. I'm getting confused. We're going to rewrite as a division problem. Thank you. Then, when we find a repeating pattern, stop dividing. then remember to add in the mixed or the whole number. Let me show you an example. So we're going to take 5 6 to a decimal. Let me move this up. Okay, so just like before in our last section, we're going to rewrite what goes where inside of the little house. Remember, the numerator goes inside and the denominator goes outside. So my numerator is here, my denominator is out here. Okay, so the question is, how many 6's go into 5? Well, 0, but I need to find out more exact. So just like before, I'm going to add some zeros into here to help me out. So now I can say how many 6's go into 50. Okay, so 6 times 10 is 60, 6 times 9 is 54, so I'm going to guess it's 6 times 8, which is 48. Okay, so I'm going to put in 8 here. 6 times 8 is 48. Subtract, I get 2. I'm going to bring down my 0. So now I have, how many 6's are in 20? Well, 6, 12, 18. 6 times 3 is 18. So I have 3. 6 times 3 is 18. Subtract, I get a 2. This is starting to look a little familiar already. How many 6's are in 20? Well, I did that already. I know it's 3. 6 times 3 is 18. I'm sure you guys can see. 2. I think I've found the pattern because I'm just going to keep getting 20 every time I do this. So I found the pattern, and when I write my pattern out, I can write it like this. 5 6 goes to 0.83 repeating, because it's just the 3 that's repeating. It's not the 8-3 that repeats and repeats and repeats. Okay? Let's take a look at another example. Let's solve that problem with Jason and his babysitter. We're going to look at example 2. Recall that he had 385 thirds. Because he got to earn 185, or sorry, she earned $385 and he got 1/3 of it. So I can't do a division problem like this just yet because it's much too large. So I first have to write it as a mixed number. So the question is 385, how many 3's go into that? Well, let's see what I can do. 3 goes into 385, and if I do it this way, I can just find a remainder. So 3 goes into 3 once, gives me a 0. 3 goes into 8 twice, gives me 6. Bring down my 5. 3 goes into 25, 8 times, right? Yep. 3 times 8 is 24, which gives me 1. So I can say I have 128, remainder 1. So that means 385 as a mixed number is 128 and 1/3, because I had 1 left, so I get the amount that I have here. Now that I have 128 and 1/3, I can use the style that I was using before. I can ignore my mixed number like I was doing, and I can do 3, so I can go check again, because I'm always mixing this up. My numerator is inside and my denominator is outside. My numerator is inside and my denominator is outside. So I'm going to need to have some zeros on this for sure. I'm going to put my decimal up, and now it's time to start dividing. 3 goes into 1 0 times. I've got 1. I'm going to bring down my 0. I've got 10. 3 goes into 10 3 times. 3 times 3 is 9. 10 minus 1 is... Sorry, 10 minus 9 is 1. Okay, I'm going to bring down this again. 3 goes into 10 3 times. I think I start to see a pattern here. Let's do it one more. 3 times 3 is 9. Subtract. I have 1. Bring down. Yep, it definitely seems like it's repeating. 3 times, how many 3s are in 10? 3, 9. My repeating decimal now is going to be 0.3 repeating, because I just need to have enough to establish the pattern. So my answer here is going to be $128.33. That's how much he's going to earn. And because I can write this as 128.33 repeating if I want, kind of like that. It doesn't really matter if I want. I should have wrote it like this and got rid of this 3 if I'm writing it mathematically. But if I'm writing it in money, I need at least 2 decimals. One of the most common uses that you'll find going from fractions to decimals is computers, because computers don't write in fractions. They do everything as decimals instead. And that's where the largest amount of converting back and forth goes. If you feel like you understand it, go ahead and go on. I'm probably going to do 2 more examples. All right. We're going to go 2 1/6 as a decimal. 2 1/6 to a decimal. Okay, just like before, I'm going to ignore my 2 out front, and I'm going to take 1/6 and then do my dividing. So I'm going to put my 6 out front and my 1 inside. And I'm definitely going to need to do some zeros after this. So how many 6s are in 1? Well, 0 obviously. 6 times 0 is 0. I have 1. I'll bring down my 10. How many 6s in 10? Oops, need my decimal. Just 1. 6 times 1 is 6. Subtract. I have 4. Bring down a 0. I have 40. How many 6s in 40? Well, 6 times 6 is 36. So I'm going to put a 6. 6 times 6 is 36. Subtract. And I have 4. Bring down another 0. I have 40. This looks very suspicious. 6 times 6 is 36. Subtract 4. Bring down this 0. 40. Yeah, I definitely have a repeating pattern here. So if I'm going to write this out, I can write 2 1/6 goes to 2.16 with just the 6 repeating. And that's going to give me my answer. Oh man, I've been terrible about boxing my answers. And I should probably box my answers in a different color. That would kind of make sense. What color do I want? This little pink thing can probably be pretty good. How's that look? Yeah, it does look good. Oh man, I went off the page again, didn't I? I am doing that a lot today. Sorry about that. There it is if you want to see what I was up to. And I'm going to do one more example. And I'll do my best to stay on the page this time. Sorry about that. Example 4. All right. Example 4. We're going to go 4/9 to a decimal. All right, my numerator, let's check it out again. My numerator goes inside, my denominator goes outside. I'm definitely going to need to add some zeros. How many 9 goes into 4? 0 times. 4 minus 0 is 4. Bring down a 0. How many times does 9 go into 40? I'm going to say 3, because 9 times 3 is... Oh, no, it's going to be 9 times 4 is 36. 4, 36, subtract. I've got 4. Bring down a 0. I've got 40. This is already starting to be suspicious. How many 9s go into 40? Well, we just did that. 4. 9 times 4 is 36. Subtract 4. Yeah, we definitely have a repeating fraction. So here we're going to have 0.4 repeating as our answer. And we can just box that with a little blue. Kind of makes sense? All right, good luck.